in this question we have to design a compensator such that the gain crossover frequency of the compensated system is equal to the phase crossover frequency of the uncompensated system. Okay, now the transfer function, open loop transfer function g of s is given as 900 by s into s plus 1 into s plus 9. So first let us find the phase crossover frequency. So omega pc is equal to 1 by root of t1 into t2, where t1 and t2 are the time constants of the components we have here in the transfer function. We have two poles, one is at -1 and one is at -9. So their respective time constants are 1 and 1 by 9. So those are the values of t1 and t2 here. So omega pc will be equal to 1 by root of 1 into 1 by 9. So that is equal to 3 radians per second. Okay, now let us find the gain margin. So g of j omega h of j omega is equal to 900 by s into s plus 1 into s plus 9. So that is equal to k into t1 t2 by t1 plus t2. Here k is equal to 900 by 9. K is equal to 900 divided by 9, and t1 is equal to, again the time constant 1, and t2 is equal to 1 by 9. So we need not use this formula also, you can just determine the magnitude by substituting the frequency as the phase crossover frequency. Okay, now so the gain margin is equal to 20 log 1 by g of j omega pc h of j omega pc. So that will be equal to 20 log 1 by 10. So that is equal to minus 20 decibel. So if we can see here, the gain margin of the system is negative. So a negative gain margin implies that the system is unstable. So for the system to be stable, the gain margin can be as much as the phase margin. So if it, that is the limit of stability in fact. So the gain crossover frequency is equal to omega gc is equal to the phase crossover frequency, which is equal to 3 radians per second. So this is the limit of stability. Now in order to have omega gc equal to 3 radians per second, we need to add a lag compensator. Okay, this will give an attenuation of 20 dB per decade. Okay, so the first compensator we need here is a lag compensator with an attenuation of 20 dB per decade, and in the question it is asked that we need to have a 45 degrees phase margin. Now again, in order to have a 45 degrees phase margin, we need to add a lead compensator with a phase lead of 45 degrees. So the system should have a Ladley compensator, okay, with a 45 degrees phase lead and 20 dB per decade of attenuation. So the correct option is D.